Now let's proceed to lesson 3, speed and velocity. First, let us define average speed. So, average speed is given by the distance over the elapsed time to cover that distance. So, speed answers the question of how fast an object is moving. So, in SI units, the average speed is expressed in terms of meter per second. However, in the CGS system, we can express the speed as centimeter per second, and for the British Engineering System of Units, we have the feet per second. Now let us solve example problem 3.1. So the problem states that how far does a jogger run in 1.5 hours if his average speed is 2.22 meters per second. First, let us write down the given. So we have the time t, which is equal to 1.5 hours, and the average speed, which is equal to 2.22 meters per second. So we are asked to find the distance d. So let's denote the distance as d. So for the solution, we can simply use the formula that speed is equal to the distance covered over the elapsed time. So for the distance, we have 2.22 meters per second, and this is equal to the distance that we are looking for and the time t, which is equal to 1.5 hours. However, we cannot simply use this one because this is expressed in terms of hours, and our speed is expressed in terms of meters per second. So we have to convert this. 1.5 hours is equal to, for every hour, there is 3,600 seconds. So we can cancel. We'll get 5,400 seconds. So we will write 5,400 seconds here. Cancel. The distance d is equal to 2.22 times 5,400. That is equal to 11,988 meters, or 11.988 kilometers. Now let's proceed to example problem 3.2. So an 18-year-old runner can complete a 10-kilometer course with an average speed of 4.39 meters per second. A 50-year-old runner can cover the same distance with an average speed of 4.27 meters per second. How much later, in seconds, should the younger runner start in order to finish the course at the same time as the older runner? So, first, let us write down the given. The distance d is equal to 10 kilometers. So, the distance is the same for the 18-year-old runner and for the 50-year-old runner. However, for the speed, they have different speed. So, for the speed of the 18-year-old runner, that is equal to 4.39 meters per second. And for the speed of the 50-year-old runner, that is equal to 4.27 meters per second. So, we are required to find the time t in which the younger runner should start in order for the younger runner and the older runner to finish at the same time. So, for the solution, notice that the younger runner is faster than the older runner. So, they will yield different time to finish the to cover the 10-kilometer course. So, let us write the time required as a small letter t. So, since the younger runner will finish first than the older runner, the time required is equal to the time of the 50-year-old runner minus the time of the 18-year-old runner. So, first, so we can substitute it this directly. So, speed is equal to the distance over the elapsed time. So, the time is equal to distance over the average speed. So, the distance for the 50-year-old runner, that is 10 kilometers or 10,000 meters over the speed of the 50-year-old runner, that is 4.27 meters per second, minus the time of the 18-year-old runner, that is equal to the same distance, 10,000 meters, all over 4.39 meters per second. So, this is equal to 1,000. This is equal to 64.0160 seconds. So, for the two runners to finish at the same time, the younger runner should start at 64 seconds after the older runner started. Now, let's proceed to the average velocity. So, the average velocity is the displacement divided by the elapsed time. So, for the displacement, we can use the plus and minus signs to indicate the two possible directions. So, for example, if the displacement is to the positive direction, the velocity is positive. And if the displacement is pointing to the negative direction, the average velocity is negative. So, again, average velocity is equal to the displacement over the elapsed time. And in SI units, it is the average velocity. So, take note that this should be velocity. It is expressed in terms of meter per second. So, however, it can also be expressed in terms of other units, such as kilometers per hour or miles per hour. Now, let's proceed to an example problem 3.3. Andy Green in the Car Trust SSC set a world record of 341.1 meters per second in 1997. The car was powered by two jet engines, and it was the first one officially to exceed the speed of sound. To establish such record, the driver makes two runs through the course, one in each direction to nullify wind effects. So figure A shows that the car travels first from left to right and covers a distance of 1,609 meters or 1 mile in a time of 4.74 seconds. So, however, in figure B, it shows that in reverse direction, the car covers the same distance in 4.695 seconds. From this data, determine the average velocity for each run. So, let us solve. So, given, we have the distance d, which is, okay, so the distance is equal to 1,609 meters. And time from left to right, that is equal to 4.74 meters. And the time from right to left, that is equal to 4.695 seconds. So, sorry, this is seconds. This is seconds, not meters. So, first, let us solve for the velocity from left to right. For left to right. So that is the velocity v. This is equal to the displacement. So in this figure, we assume that the positive direction is to the right and the negative direction is to the left. So since we are considering from the left to right first, our displacement is positive. So positive 1,609 meters over the time elapsed, that is equal to 4.74 seconds. So this is equal to 339. This is equal to positive 339.45 meters per second. So for the right to left, we will have, so since we are going to the left, our displacement is negative 1,609 meters, and the time elapsed is equal to 4.695 seconds. This is equal to 342.70 meters per second. So we have these two answers. This is negative 342.70 meters per second. Now let's try to solve example problem 3.4. So, starting from the front door of your ranch house, you walk 60 meters due east to your windmill. So, this is 60 meters. And then you turn around and slowly walk 40 meters due west to a bench where you sit and watch the sunset. For example, this is the side view of a bench. This is equal to this is 40 meters. It takes you 28 seconds to walk from your house to the windmill. So, house to windmill, that is equal to 28 seconds. And then 36 seconds to walk from the windmill to the bench. This is 36 seconds. For the entire trip, from your front door to the bench, what is A, your average velocity, and B, your average speed? So for the solution, let us solve first letter A. Average velocity. So remember that the average velocity is equal to the displacement over the time elapsed. So the displacement is equal to positive 60 meters minus 40 meters. And for the time, we have 28 seconds plus 36 seconds. So we have a displacement that is equal to 10 plus 0.315 meters per second. So this is positive, meaning you are due east. And letter B, for the average speed. So we have the speed is equal to the distance over the time. So this is equal to, notice that this is distance, so we have to disregard the sign. So this is 60 meters plus 40 meters all over 28 seconds plus 36 seconds. So this is equal to 1.56 meters per second. Now let's proceed to instantaneous velocity. Suppose that for a certain trip, your average velocity is 20 meters per second. So that is only the average. There are instances that your velocity is less than or sometimes greater than 20 meters per second. So the your velocity at a certain instant is called the instantaneous velocity. So the instantaneous velocity is given by the limit of the displacement divided by the change in time as the change in time approaches to 0. So let us have the example problem 3.5. So a car is stopped at traffic light. If it then travels along a straight road so that its distance from the light is given by the x as a function of time is equal to pt squared minus ct cubed, where b is 2.40, so this is 2.40 meters per second per square seconds, and c is equal to 0.120 meter per second cube. So calculate the average velocity of the car for the time interval t is equal to 0 and t is equal to 5 seconds. And B, calculate the instantaneous velocity of the car at t is equal to 0, at t is equal to 5 seconds, and t is equal to 10 seconds. And lastly, how long after starting from rest is the car again at rest? So, for letter A, the average velocity of the car for the time interval t is equal to 0 to t is equal to 5. So first, we have to solve for the position of the car at time is equal to 0 and at time is equal to 5 seconds. So first, we have at time is t is equal to 0 seconds. So we can calculate the position by substituting 0 to the equation x is equal to b t squared minus c t cubed. So this is equal to 2.40 meters per second times t squared, that is equal to 0 second squared, minus 0.120 meters per second cube. So this is squared, times d time t, which is 0 seconds cube. So at time t is equal to 0, x is equal to 0 meters. So at time t is equal to 5 seconds, we can substitute x is equal to 2.40 times 5 squared minus 0.120. So 0.120 times 5 raised to 3. So this is equal to 2.4 times 5. So this is equal to 45 seconds, meters. Sorry, this is 45 meters. So to get the average velocity of the car, that is equal to the displacement over the time. So this is equal to 45 meters all over the 5 seconds. So this is equal to 9 meters per second. For letter B, we are asked to calculate the instantaneous velocity of the car at t is equal to 0, t is equal to 5 seconds, and t is equal to 10 seconds. So we have the equation for the position at certain time t. So remember that the velocity v is equal to the change in displacement, change in position with respect to the change in time. So we have to differentiate this equation in order to get the equation for velocity. So we have v as a function of time. This is equal to the 2bt minus 3 minus 3 ct squared. So substituting, we have to substitute the time to get the velocity. So for at t is equal to 0, the velocity is also equal to 0 meters per second. At time is equal to 5 seconds, velocity v is equal to 2 times 2.4 times the time t, which is 5, minus 3 times 0.120 times 5 squared. So this is equal to 15 meters per second. Okay, for a time time t is equal to 10 seconds, we will simply substitute 2 times 2 times 2.4 times 10 minus 3 times 0.120 times 10 squared. So this is equal to 12 meters per second. So we have the following velocities. We have the following instantaneous velocities. So for each given instant. So now let's proceed to letter C. How long after starting from rest is the car again at rest? So we have to use this formula in order to get the time. So we sub t is equal to 2 times 2.40 t minus 3 times 0.120 t squared. So we are looking for time t, and it states that the final velocity is 0. So 0 is equal to 2 times 2.4 times t minus 3 times 0.120 t squared. So t is equal to 13.33 seconds. So this is 13.33 seconds.